All right, today we are going to break down a true classic of system design interviews, Design Dropbox. But we're not just going to sketch out a basic file service. Oh no. We are going to architect the perfect staff-level interview answer. I'm going to show you how to think beyond the junior-level solution and really demonstrate the kind of architectural thinking that lands you that senior role.
Okay, picture this. You're in the interview and they drop the prompt. Now, what's the first thing you do? Your gut might be screaming, whiteboard, let's draw some boxes and arrows. But nope. A senior engineer knows the first and honestly, the most critical step is to pause and ask questions. We need to clarify the requirements and define the sandbox we're actually playing in.
You see, a staff-level answer begins by framing the problem. Before you draw a single thing, you've got to show the interviewer you're a strategic thinker. And that means getting crystal clear on not just what the system will do, but also what it won't do. It's all about setting the scope.
So let's keep it focused. We'll say the core functions are upload, download, sync, and share. And just as important, we'll explicitly call out that real-time editing, like in Google Docs, is out of scope for this version. Doing this shows you can manage a project's scope and prioritize what's important. Okay, with our features defined, now we get to the really interesting part. This is where the core challenge of any big system lies, making trade-offs. We want it to be always available, super fast and perfectly consistent, but, we can't have everything all at once. The first big trade-off you need to identify is the classic battle between availability and consistency.
So here's the crucial decision. For Dropbox, we're going to prioritize availability. It's totally fine if a file I upload in New York takes a few seconds to show up for my colleague in Tokyo. Now compare that to a stock trading app. That has to prioritize consistency. A stock purchase needs to be reflected everywhere, instantly. By stating this trade-off up front, you're signaling to the interviewer that you understand fundamental distributed systems concepts like the CAP theorem.
All right, let's start sketching our high-level design. Now, a very common interview mistake is to start way too complex. Instead, we're going to show some real engineering thinking by starting with a simple, maybe even a little bit flawed, model, and then we'll iterate on it.
So here's our first draft. The client sends a file to our server, we save it right onto the server's hard drive, and we jot down some info about it in a database. Simple, right? I mean, it works for a little project you whip up over a weekend, but a senior candidate is going to immediately see why this will just completely fall over at scale. So what breaks first? Just think about it for a second. What happens if that single server crashes? Poof! And how in the world are you going to store millions of terabytes of user files on one machine's hard drive? The two big killers here are reliability and scalability.
The answer is you don't solve a problem that's already been solved. We offload all that heavy lifting to a specialized service like Amazon S3 or Google Cloud Storage. Blob storage is built for exactly this. It's basically infinite, it's incredibly durable, and it's cost-effective. This is a key pattern in any modern system design.
Okay, we've got a core building block in place. Now we refine the design. We're going to iterate from a pretty good solution to a great one. This kind of evolutionary thinking is exactly what interviewers are looking for. It shows you know how to weigh trade-offs and improve a system over time.
Now this is way better. Our application servers are no longer the bottleneck for storage space. We take the file, we pass it along to blob storage, and then we update our database. It's definitely more reliable and scalable. But we've just created a new bottleneck. Can you spot it?
And there it is. Our server is still stuck right in the middle of the data path. Every single byte of every single file is still flowing through our service. We're just acting as a slow, expensive middleman. This is more reliable, sure, but it's still not truly scalable.
The staff-level solution is to separate what we call the control plane from the data plane. So the client first asks our service for permission. That's the control plane. We check who they are, and we generate a special URL. Then the client uploads the massive file directly to blob storage. That's the data plane. By getting our servers out of the way of the actual file transfer, the whole system becomes faster, cheaper, and way, way more scalable.
This pre-signed URL is the magic key here. Think of it like a temporary, single-use token that gives the client direct access to a specific spot in our storage bucket. Our backend manages all the permissions, but the actual data transfer, all the heavy lifting, happens directly between the client and the storage service. And for downloads, we use a similar optimization trick. Downloading directly from one central blob storage location is going to be super slow for users on the other side of the planet. So the solution is a content delivery network, or CDN. This caches popular files in data centers all over the globe, so users always download from a server that's physically close to them.
And now for a classic deep dive question that really separates the senior candidates. The interviewer leans in and says, "This all works great for small files, but what about a 50-gigabyte video file?" This is your moment to shine. So let's just do some quick math. A 50-gigabyte file on a decent internet connection could take over an hour to upload in one go. That single request is absolutely going to time out. Not to mention, if your connection drops at 99%, you have to start all over again. It's just a complete non-starter.
The solution is chunking. It's kind of like mailing a 1,000-page book. You don't send it in one giant, risky package. You send it chapter by chapter. The client breaks the large file into smaller pieces, maybe 5 or 10 megabytes each, and uploads them individually. This lets us do parallel uploads, show a real progress bar, and most importantly, resume uploads if they fail.
But a staff-level answer doesn't just say chunking. It discusses the implementation trade-offs. The simple way is to just let the client tell us when it's done. That's fast for the UI, but it's not secure. The robust approach is server-side verification. Our backend needs to ask the blob storage service directly, "Hey, did you actually get all the chunks?" before we mark that upload as complete. The idea is trust the client for a smooth experience, but always verify on the server for data integrity. We've totally nailed the core upload and download problems. So now let's talk about the magic that users actually see. Synchronization. How does a file I save on my laptop just instantly appear on my phone? This final part is all about sync and security.
So to keep files in sync, a user's laptop needs to know when a change happened on their phone. The simple way is polling. The client just asks the server, anything new, every few seconds. It works, but it's super chatty and slow. The advanced solution is a WebSocket, which keeps an open connection so the server can push updates to the client the moment they happen.
But what if that WebSocket connection drops for a minute? The user might miss an update. So the most robust production-ready solution is actually a hybrid model. We use WebSockets for those instant real-time updates, but we also have the client poll the server every few minutes, just as a safety net. This gives us speed and reliability. It guarantees eventual consistency. And one final, crucial point. Don't wait for the interviewer to ask you about security. Bring it up yourself. A staff-level answer has to address encryption, both in transit using HTTPS and at rest using the built-in encryption of your blob storage service. This shows you build systems that are secure by design. And finally, to leave the interviewer completely blown away, you can end with a forward-thinking question. It shows you're not just solving the problem in front of you, you're already thinking about the next evolution of the system. This moves the conversation from, "Can you do the job?" to "How would you lead this project?" And that is exactly where you want to be.